for dissemination purposes.
Okay, let me welcome you everyone in this webinar for the open call to candidates. I am Tertsi Valvasaki from Snellic Solution, Technical Coordinator of NEMO, and I am going to give you a brief introduction on the project. We will start by some information about the project identity, the consortium, our motivation and vision, and how this is reflected in the work plan, the NEMO technology, and the validation activities. So starting by the identity details, NEMO stands for Next Generation Meta Operating System. It is a real project that is coordinated by Atos, technically coordinated by us, Snellic, and it is supposed to be active until the end of August 2025, which is 3 years duration. The EU contribution is 10.5 million euros, and we are a big consortium of 26 partners from several verticals, including large industries, telecom operators, labor labs, a good number of SMEs, research institutes and universities, and also Eclipse for building the open source ecosystem. And as you can see, we have a good geographical coverage across Europe. So what is the motivation behind NEMO and the concept of this meta operating system? First of all, we have been driven by the fast-growing Internet of Things. So several types of systems, several kinds of devices, several kinds of capabilities, artificial intelligence that is aimed to be present at every aspect of our life and every device that accords us. And also by the imminent evolution of a big range of applications that can leverage these two capabilities, the artificial intelligence and IoT, into the artificial intelligence of things. However, in order to fully realize this vision, we are still challenged by the lack of sufficient real-time, secure, and trusted support from the IoT and edge side, and also the lack of support of bringing intelligence very close to the data in real-life scenarios. So our vision in NEMO is on one hand to support on-device intelligence in order to enable this AIoT vision, to build a transparent continuum from IoT to edge to cloud, leverage on intent-based capabilities for automated DevOps tools and functionalities, build an open and modular meta operating system, and enable massive applications, IoT applications that make use of all these capabilities, and hopefully to achieve the high penetration starting from these two open goals. We can graphically see this vision of this cluster-based setup of devices that welcome a big stream of diverse data flows with different characteristics. Based on this, we have several capabilities for building artificial intelligence that is used by this big range of applications, and which will allow a large community to develop on top of this and monetize either their resources, their data, or even their applications capabilities. So NEMO aims to build a meta operating system. What is this? It refers mainly to a multi-class and multi-network orchestration of containerized workload. And this should happen in a consistent manner across the different levels of the continuum, including low-end IoT devices, and allow different types of stakeholders like cloud infrastructure providers, workload application owners, but also data providers to collaborate and monetize their resources, and this to be done in a user-friendly way. I will go on with some details on the technological capabilities of the Meta operating system that are relevant for being considered in building applications on top of this Meta operating system. So why one should select to bring their applications into what we call Meta operating system. First of all, we enable federated network management. So we built this functionality on our federated Meta network cluster controller. This builds on SDN capabilities for the different types of the containing different types of clusters. So interconnecting services that can run in multi-domain, multi-path scenarios, multi-modal, different types of networks like wired, 5G, wireless, public, private, and even different types of capabilities, including devices both on the IoT, the edge, or the cloud side, and being able to express the network requirements in a declarative manner by supporting intent-based network management. The next set of functionalities, I would say, refers to the homogenization of workload orchestration. This is done in the NEMO kernel functional layer. And here we consider the homogenized orchestration of workloads in multi-cluster, multi-domain scenarios, addressing device diversity, including low-end devices, and enabling in a consistent manner observability and workload discovery, automated policy enforcement, and always considering capitalizing on energy and carbon efficiency. Our next objective is towards providing federated service management. So this is the upper layer that exposes our functionalities, the NEMO functionalities, to external users. This is done in developers friendly and programmatic manner, similar to what is already familiar to application developers. And apart from this, NEMO supports smart contract-based accountability, leveraging on the token-based billing mechanism that also respects and supports data sovereignty and traceability through integration with blockchain. And part of this layer is also consistent life cycle management for the diverse types of workloads that run in the continuum, considering role-based access control and enabling workload awareness, traceability, and control on top of the Meta operating system. Another significant capability that is enabled is the liberation of artificial intelligence. So NEMO exposes federated machine learning operations as a service to external users, which means that there are interfaces to in programmatic capabilities for third-party developers to either develop machine learning on top of the Meta OS or run machine learning services and either share or serve their models through our system. This layer also builds on federated and reinforcement learning capabilities. making use of collaborative training, and also ensuring security through intrusion detection and mitigation. Next is the press and policy enforcement. This is considered all levels in the architectural vision in NEMO in an automated manner. It covers, on one hand, automated policy enforcement in accessing data that come from the workload. So enforcing access control in the APIs of the running workloads. On the other hand, we enforce policies on the operation of the workloads, again in an automated manner, and these policies are user-driven, which means that are based on intents that are user-defined, and also considering both the network and the kernel spaces, so referring to both network and computation requirements, and leveraging on AI decisions, AI capabilities that assist the decision on the policy enforcement at the relevant policy decision points. Last, I would like to note that NEMO as a platform is aimed to be offered as a community project. We leverage on a common API for external users. We also support extensions on the NEMO capabilities as plugins, and this was also the objective of OpenCall 1. The whole project is offered as open source in Eclipse Research Labs GitLab, and we aim to be extended through this OpenCall and adopted through OpenCall 2. Now, how the work is organized within the project. We have 7 core packages. The first one deals with the technical design specification. That fits the technical development in core packages 2, 3, and 4. And this ends up to an integrated framework that is validated through the pilot activities in core package 5. Then we have core package 6 for impact creation and outreach, and project management and open goals management in core package 7. This is the functional vision, how the different capabilities that were presented before are organized in the different layers within the NEMO architecture, including the underlying technology, NEMO kernel, service management, and also as vertical components, the machine learning operation capabilities, present policy enforcement, and cybersecurity operations. And here we see how extensions can be possible in the system. Additional functionalities can be developed and imported as plugins, as in OpenCall 1. And then applications can be deployed, can be integrated into NEMO through the intent-based SDK or API that we hope will serve OpenCall to use cases. Now we move on to the validation activities of the project. We have 5 living labs and 1 IoT 5G lab. It covers the validation activities cover 4 verticals: smart farming and precision agriculture, smart energy and smart mobility, smart manufacturing and industry 4, last but not least, smart media, smart city, and XR. So in total, we have 8 use cases, and hopefully this will be extended with 10 additional ones through this open call number 2. Starting with the smart farming trial, the Living Lab is located in Monovasia, Greece. The objective is to enhance and support the bioagricultural activities in an olive grove in Greece. On one hand, ensuring that we have a high quality of olives and olive oil produced. On the other hand, ensuring that this is done in a sustainable and efficient manner in terms of resource utilization and without compromising the organic certification. Here we have 2 use cases. And the first one refers to aerial precision biospraying. And here we use data measurements that come from sensors attached in Synalex's Infield IoT devices. We also combine those with the real-time video analysis of images that are captured from a camera that is attached on a drone. And the objective is to identify the trees that need to be, for which biospraying needs to be applied. We do this based on machine learning models that could run on directly on the end devices, the drone, or they could be flexibly allocated at some other level of the continuum if NEMO decides so, driven by the set requirements in terms of also energy efficiency and consumption, and such decisions are assisted by machine learning operations and the capabilities for flexible deployment orchestration of these workloads that are involved in this trial across the different IT agent cloud resources. The second use case deals with terrestrial precision agriculture, and here we have an autonomous mobile robot equipped with a set of sensors and camera. And the objective here is to manage the weeds that are developed among the trees. Here we leverage on machine learning models for the autonomous movement, the autonomous navigation of the mobile robot across the field, and also for object detection, collision avoidance with the trees and humans. And here the objective is to benefit from NEMO capabilities in order to do this in an effective manner, both in terms of performance of the machine learning models, which means we want zero collisions, and on the other hand, to do this in a manner that makes best use of the available resources. We move on to the smart energy and smart mobility trial. The Living Lab here is located in Terni, Italy, and the objective is to validate the NEMO capabilities in monitoring and stabilizing the smart energy grid. On the other hand, we consider the electric vehicles and dispatchable charging of those in order to achieve load balancing of the energy that is renewable energy that is produced from the dispersed sources like photovoltaic channels. And on the other hand, here we aim to predict the traffic flow and the parking spots, making use of data that come from available cameras to the devices that are involved in the trial in order to assist a driver-friendly scenario and also support eco-mobility combining crowdsourcing data. Here we have, again, two use cases. The first one covers the two first objectives that refer to smart grid flexibility. And here we use voltage quality data coming from smart meters, phasor measurement units, and power quality analyzers in order to feed advanced analytics for predictive maintenance at different levels of the continuum and of the energy management system, and enabling us to forecast the power flow, to identify discrepancies in the local energy grid, coming down to the IoT level, and also enable more effective protection at the edge level. The second use case deals with the smart mobility scenarios. And the aim here is to make use of the images and videos that come from cameras and that are located in the trials devices, attached in the trials devices, in order to fit machine learning models for traffic flow and parking prediction. And on the other hand, to support dispatchable charging of the electric vehicles, considering the available charging points, and enable demand response scenarios for supporting flexibility services targeting renewable energy sources, while at the same time integrating a human-centered smart micro-contracts, micropayments mechanism in a relevant blockchain-based marketplace. The third trials deals with Smart Industry 4 validation. And here the pilot is hosted by Continental in Ingolstadt, Germany. The objective here is to enhance the operations that deal with the mass production and safety, worker safety within the factory, including high levels of automation and enabling collaboration of humans with these autonomous or semi-autonomous devices, including both cobots, collaborative robots, and automated guided vehicles, what we call the AGVs, within the factory. And in order to achieve this, we should also take care of high-speed connectivity within the factory, so through private 5G networks set up in there and synchronized with the local acquired network, and also considering the analytics that are fed from multi-scope sources, including sensors, cameras, and RFID nodes, in order to enable the prediction of relevant collisions, either between humans and devices or between the devices themselves. Here again we have two use cases. The first is on the material picking side. So leveraging on machine learning models to identify and support material picking through cobots, and then support the autonomous transfer from the auto store to the production line through the cobots. And this trial also, this use case involves the connectivity scenario, high-speed connectivity scenario, validating the PSM functionalities that are developed in the project, in order to support the communication and data feeding at the required pace for supporting automated autonomous navigation of the relevant AGVs. The second use case deals with human safety and which refers to the workers and again using AI functionalities in order to detect them at the level of the moving AGV and be able to take relevant control action in order to avoid the collision with these human workers. So again, the objective of the role of NEMO is, on one hand, to ensure that the AI functionality works in an effective manner and that information is fed at the required latency and speed, and the inference takes place quite fast in order to support this in a real-time scenario, and with the possibility to have these operations running either directly on the AGV or at some other device within the factory. Last but not least, we have a smart media city and XR validation. This living lab includes two diverse, I would say, use cases. They are both located in Rhinos in Greece, in Athens. The objective on one hand is to validate the NEMO capabilities to support augmented content in a live event like the Athens Marathon. And on the other hand, to validate the NEMO capabilities in XR, extended reality scenarios, which means that we should consider high levels of interactivity, low latency, and high levels of accurate analysis of the relevant gestures or emotions. The first use case deals with the round of Athens. Here we consider the case of enhancing the spectating experience. So receiving information from IP cameras that are located at different parts of the street across the route of the marathon. Also from cameras on flying drones, but as well from user smartphone devices, and use them in real time in order to provide personalized content augmentation, referring to the athletes to the runners that participate in the marathon. So there are several challenges which deal with the moving object that needs to be identified, different and highly dispersed cameras, the need to combine input from all these sources, and also the requirement to make efficient use of the resources we have for this, because it is highly demanding in terms of content and network requirements. And the last, we have these two XR use cases. The first one deals with a virtual reality experience in an ancient workshop of sculptor Phidias. These two are both hosted in the foundation of Hellenic work premises. And the second use case deals with enhancing the AV experience in the Tholos Dome VR theater. So in both cases, We use input that comes from different sensors, either collecting data from the participants, the visitors, or even cameras that capture the gestures of the workers there, the guides. And the aim here is to enable emotion recognition during the HMD experience and gesture recognition during the VR Dome experience. Again, ensuring that this takes place at a highly efficient manner. Last, we have included here a table that includes the functionalities of NEMO as supported by the relevant components that are validated in each of the living labs. Just for reference, I'm not going to talk about them one by one, but as you can see, all of them are validated in at least one of the living labs. So we expect to extend the pilot activities in each of the labs with this second open call. Last, before closing, we have the project envisions a sixth trial. It has not started yet, but it starts soon, which refers to the federation of several living labs, and this deals with investigating scenarios of how we could combine the resources that are available or the functionalities that can run in cooperation across different clusters or MetaOS instances. So considering cross-platform scenarios and involving a big number of diverse devices that could be available in the different living labs. So that's all from my side. Thank you very much for your attention. We could move now to the next presentation, and at the end we have a Q&A session to answer collectively to any questions that may arise.
Thank you very much, Terpsi, for your presentation. Allow me to share my screen and start the other one. Fortunately, there is an issue with my camera and I cannot open it, but hope it's all right for you. Okay, can you see the screen?
Yes.
Okay, thank you very much. So, hello everybody, my name is Dimitrios Kias, representing Net Company Intrasoft. We are the Open Call coordinators for the NEMO project, and this presentation will give you more information regarding the NEMO Open Call 2. So more specifically, we will discuss the topic of the open call. We will give some guidelines and the operational procedures, and also some useful links for you to be aware of and look through them, through the information provided through them for you in order to prepare your application. So NEMO already ran the first open call, but main objective was to extend the technologies built within NEMO project. So we invited the SMEs applicants to provide this sort of extensions in terms of that would extend also the architecture of the NEMO and provide additional tools. There are some details about that, just for you to be aware, because currently Open Call 1 projects are in the development phase, and sooner or later would be an actual part of the NEMO project, of the NEMO MetaOS platform. So for the second Open Call, what is the objective? The objective is now to validate user acceptance and boost the adoption, the massive adoption and sustainability for the NEMO project. For that reason, we invite EU-based SMEs to extend now the NEMO use cases as presented previously in the context of the limit labs and port new and existing application services that will be built by these projects and services into the NEMO MetaOS and will be validated within NEMO Living Labs quite significantly. The outcomes of this work for all of the projects will be open source, given that NEMO is a strongly open source project and we aim to promote as much as possible this direction. And the total funding for the second open call in NEMO is 900,000 euros, allowing for each partner to receive up to 90,000 euros. And this is because we follow, let's say, a funnel approach that I will describe in a bit that dictates the procedure, the execution procedure of the open call. So if you see on the right window, in total 12 grants, 12 proposals will be accepted. Thus, we believe anyone trying to apply for the second open call have significant chances, given the high quality of the proposal, of course, to be accepted. In general, the open call time window for applications has opened on 1st of June 2024 and will close on 31st of August 2024. The duration for the project implementation activities will be 9 months. And more specifically, the projects will start designing, implementing, and then providing some business, let's say, conducting some business work from the 1st of December until the 31st of August. As I said before, the funding for each proposal will be up to 90,000. Quite importantly, I have some links here placed available for you. The first one concerns the application, let's say, service that we have through F6S platform that you can apply and prepare your proposal in order to submit it and then hopefully be accepted by the project. So the link is here. I will give to you also at the end, and maybe we'll make available, the links are already available in the website, but I will give you some guidelines about that. And of course, we have the majority of the information that concerns the open calls within our website, that is metaos.eu, link at the bottom. And you can review within there additional information, useful links, and the documents that we have prepared that aim to help you build your proposal. More specifically, the applications now, setting the objective, let's say that we aim to you would need to build for the second open call, would need to adhere to some requirements in order to be demonstrated and included by the NEMO MetaOS. So we need to have high device heterogeneity support from these applications, including low capable IoT devices, possible. On-device machine learning, it's a good requirement to have. Low latency, high bandwidth, it is also a needed requirement. Energy efficiency is quite an important objective for the NEMO project in general, so it would be needed to look on these aspects as well. And should provide to the sustainability also aspect through data resource and service that this application provides to the NEMO. Pretty much this is the topic. Now, a few words about the timeline of the project. As I said before, the call was announced on the 1st of May and we opened the submission window from 1st of June. Currently, we are in this second step presenting this figure. At the beginning of September until November, we will evaluate the proposals. Top 12 will be selected. Then we will prepare the subcontract agreements. And by 1st of December, these projects will start their activities, and the activities will conclude at the 31st of August, which is also aligned with the project per se duration. So these projects will be with us for the rest of the duration of the project. Some information that are quite important concern the stages and the execution procedures for the projects that will be selected. So initially, as I said before, 12 projects will be selected, and starting from the 1st of December 2024, we find the design phase that will last for 2 months, and in total, the funding that concerns this stage is 20% of the 90,000 that is available. Then we have the experimentation phase that concerns the implementation and validation activities. I will give you some more details about each phase in a bit. Here, the 10 top projects will be selected. So unfortunately, 2 will have to be disqualified. So this is a good opportunity to compete and increase, let's say, the quality of the results provided. This is the most significant phase, will last 6 months and covers in total the 90% of the as a lump sum of the funding available. And we will have the growth phase at the end, which will last 1 month and concern business exploitation activities. Some more information for each phase. So during the design phase, 2 months duration, each project needs to provide the application concept, ideally a mock-up or an early prototype of the application, and also some high-level tech business presentation. This will be included in relevant deliverables and will be evaluated by external experts after 2 months. Then we move to the experiment phase. We reduce the projects running from 12 to 10. Here, the main objective for the project is, for each project, is to provide the minimum viable product, MVP that we call it. This is to implement actually the application of the service, bringing to the project, and to conclude on the validation activities within NEMO. Of course, the technical outcomes, as I said before, will be provided as open source, and this concerns any tools and applications that would be built from this project. So at the end, having a duration from 1 month, the top 6 projects now, the most prominent ones, will have to to proceed on some promotion activities and exploitation activities for their solutions, and ideally engage new customers, partners, investors through meetings, conferences, and other various events that may be able to participate in. So this is the stages. Quite importantly, we have some piece of information available through these links. These links are also available in the annexes, in the associated documentation that is of the second open call, available from our site, that is metaos.eu. You can join there and can find information about the open calls per se. You can find the associated documentation, links for the success platform in order to manage your application and to ask any question if you have any. This is the documents needed for you to review them in order to prepare the proposal. The first 2, especially the Annex 2, would be the most significant for you. It contains all the necessary information for you to understand what you are required, let's say, to do in order to prepare your proposal. There are information about the procedure, stages, eligibility information, etc. And all the relevant information is included in this document, and the rest documents are needed also to be included during your proposal submission. So please go look at them as well. So some also additional information very, very quickly. As I said before, OpenCall 1 projects are already running and currently are in the implementation phase. For this OpenCall, we'll try to extend the meta architecture, providing software components and solutions to do that. Again, SMEs will be the eligible organizations for this OpenCall, and we have selected 6 projects, the top ones from the applications that we received. So you can see here the topics that will have extensions, let's say, and additions and refinements over the tools that are natively built within NEMO project. So we will have extensions related to machine learning, improving precision, let's say, of the models from an innovative solution that is being is brought by Metafox. Also, we have orchestration enhancements with respect to the MetaOS edge resources and the management. So here we have orchestration monitoring enhancements, augmented reality applications. So here we port augmented reality devices and associated interfaces and tools are built. We have also analytics, ML-based applications and interfaces for the smart energy use case. Gateway edge for NEMO system. This allows the porting of the NEMO to proprietary hardware platform. So this extends further the hardware side that is interconnected to the NEMO. And finally, MariNEMO, which aims to enable the MetaOS to build to support so-called maritime applications and relevant use cases. Pretty much this is my presentation, explaining the procedure on the topic, the funding of the NEMO open call.